So the final topic we're going to discuss today will be yet another case study. This is one that is interesting because it illustrates some combinations of features we really haven't looked at in great detail yet. And basically, this case study shows how to use Project Reactive features to implement back pressure strategies between a publisher and a subscriber that conditionally run in different threads in different scheduler contexts. And so you can get this example in the EX2 project in my Reactor folder in my live lessons GitHub repository. So here's the EX2 project, and let's go take a look at what it does. So this shows how you can check the primality of a flux of randomly generated integer objects using a publisher that runs in one thread context and a subscriber that conditionally runs in a different thread context. So if we choose to run this concurrently, the publisher and subscriber run in different scheduler contexts. So let's go ahead and take a look and see how this program works. We come over here and we make ourselves a new publisher scheduler by using the scheduler's new parallel factory method, which makes us a publisher that has a single thread in the thread pool. And then we go ahead and make ourselves a subscriber scheduler. And this may or may not run in parallel relative to the publisher scheduler. You'll see how that works. If we want it to run in parallel, it runs in parallel. If not, it runs in the same scheduler as the publisher. We then make ourselves a blocking subscriber. And this approach is actually quite similar to the blocking subscriber we looked at in one of our previous case studies, case study EX4. We just modified it for this example. And then we contain another field which will keep track of all the scheduler and publisher and subscriber references that we want to be able to dispose in one fell swoop. So let's take a look now at the main program. So the main program is going to go ahead and make a new EX2 object, and then it will run it, and it's going to give it a method that's going to check to see whether an integer is a prime number or not. So we've looked at this algorithm before. I won't spend much time on it, but it basically does prime number checking. Here's the EX2 constructor. As you can see, it parses the command line arguments, which are useful to set different properties, like do we want to run the publisher and subscriber in different threads or not? Depending on whether we want to, if we're running in parallel, we're going to make ourselves a new parallel scheduler, which we call subscriber, and we give it a parallelism count. So we can actually run these objects, we can run the prime checking in one or more threads, which is kind of cool. Otherwise, if we don't want to run in parallel, we go ahead and run everything in the publisher's scheduler. So that in that case, the subscriber and the publisher will be the same. We're then going to take the publisher scheduler, the subscriber scheduler, and the subscriber, and we're going to go ahead and put them into this disposables field so we can remove them all at once together. Okay, so that's the constructor. As you can see, we make the object, then we call the run method, and the run method takes the prime checker and the name of the test, which as you can see here is pub sub prime checker, and it does the following. The first thing it does is it generates a list of random integers, and you can see it does this by using the random object, so it makes a stream of values, and it converts the stream to a stream of ints to integers, and then it makes a list, so that's pretty normal. So we have a list of integers. Then we're going to go ahead and make ourselves a prime check function. So we take the prime checker, and we make a prime check function, and you can see what that does is it's going to take the, we're going to go ahead and create ourselves a function that will take a number, run it on the appropriate scheduler, the subscriber scheduler. It's going to publish on the subscriber scheduler, and then it's going to check to see if the number's prime or not. So this is what the subscriber does. It basically is going to check for primality. And that comes back and it's stored in a local variable called check for prime. We then take the check for prime method, and we're going to pass it in down here, as you can see. But before we do that, we call a factory method called publish integers. You can see the publish integers takes the publisher scheduler and the list of random integers. And what it's going to do is it's going to create an emitter, which we'll look at in a second. Once it has the emitter, it's going to use the factory method on Flux called create to use that emitter to emit a stream of random big integers, or rather random integers. And then it's going to go ahead and subscribe on the publisher scheduler. So let's go see what get emitter creates. So get emitter is a factory method that's going to make an emitter. And make emitter is shown here. It returns a consumer to a Flux sync. And here's how it works. We basically pass it an iterator that contains all of the random values that we generated with our make random number method. And then while the iterator has any values left, we're going to go ahead and take the next item, next random value item, next random integer, and we increment a count of the number of items that are pending to be processed. And if we have not been canceled, we publish the next item. So you can see we do that for all the items in the iterator. And when we're done, we tell the sync, hey, we're finished. So that'll generate the onComplete method. So basically, this emitter is going to create a Flux stream of integers. And that stream is then created here, and it runs in the context of the schedule that's passed in. So in a nutshell, what we saw here was a way to create a factory that generates a stream of random integers in the publisher scheduler. We can then log information if we want to. We'll skip over that for now. Then we apply the flat map transforming operator. And what transform does is it takes the check for prime function and goes off and checks to see if it's a prime number or not. And we're going to remember the check for prime operation that we're running here is this guy. And it's going to do its thing on the subscriber scheduler. So it's going to publish on the subscriber scheduler. And you can see here that so what this is saying in a nutshell is we're publishing in the publisher scheduler, and then we're checking in the subscriber scheduler. So we have one thread that's generating data, one thread that's subscribing and processing the data. And then we use the subscribe method to pass in the blocking subscriber. And then we simply wait for all the processing to be done. We block until we're done. And when we're finished, we print the results. We haven't looked at the blocking subscriber yet. This should be very familiar to you now because it's basically the same thing that we had done in case study EX4. Just a few variants because we're doing a different kind of processing now. So you can see that blocking subscriber is a subscriber. It's also a disposable, so we can dispose of it. Keeps track of the number of items that are pending, keeps track of the subscription, keeps track of whether it's been disposed, keeps track of its countdown latch, and so on and so forth. And so you can see here that the constructor is going to set those fields, and then the onSubscribe method is going to create the countdown latch with a value of 1. It'll tell the subscription object, send the data as fast as you possibly can. And then we implement the various hook methods that are going to be provided by the subscriber interface. And as you can see on successful results, we just print what the result of the prime checking was and decrement the pending item count because we consumed one of these things. On failure, we print the failure, and then we release the countdown latch. And also on success, on complete, we print that we're done, and we also release the countdown latch since everything's finished. Here's the await method. It just waits for the processing to be done. So given all of that, let's now go ahead and run this stuff. And you can see this is what it looks like. And it's going to go ahead and generate a bunch of values. We'll first see it publishing all the values. So you can see that in thread publisher 1, because that's what we called it, it's generating these random numbers. And it's also keeping track of the number of items that are waiting to be processed. Because that call runs so quickly, the subscriber thread really hasn't even had a chance to start doing anything yet. So all the subscriber operations run after the publisher is finished. If we gave it a big enough value, then there'd be interleaving of publishers and subscribers because they really can, in fact, run in parallel. So then the subscriber thread is going to be taking the values and checking to see if they're prime. And of course, if they're an even number, they'll be evenly divisible. If they're odd, they might or may not be prime. And you can see that most of these values are not prime. And it all depends on the luck of the draw. This one turned out to be prime. So you can see here, that one was prime. And they're, depending on how often you run this and what the values are, you may or may not get prime numbers very much. So that's basically an illustration of how the program works by default. Now, there's one more thing I want to show you because it's kind of fun. So if you come over here and you take a look at the options, you'll see that there's a whole bunch of options you can set. And one of the things that you can do is set the level of parallelism using the capital P option. So that's going to default to 1. But if we want to make it higher, like P5, now we're going to get 5 threads in the subscriber pool. And let's see what happens when we run that. So we should probably get a bit more processing done here. Let's see. They're all running in the same subscriber. But let's try to crank up the count a bit more. We should probably see some differences then. So if we do 500 of these guys instead of 50, you might see something more interesting. So now you can see that the subscribers, there's subscribers that are subscriber thread 5, subscriber thread 4, subscribers thread 2. So there's a bunch of different threads that are doing the processing now. And let's see whether or not we were able to get some interleaving of publishers and subscribers as well, or whether they still all waited. Now you can see there's subscriber 3. So now we're getting more parallelism in our program, which is great. That's exactly what we want to see. And each of those are going to be handling different things. As you can see now, we're still all waiting until everything's emitted before the processing takes place. Out of curiosity, I haven't tried this in a while. If we give this thing 5,000, let's see whether or not we get a different result. What I'm really interested in here is finding out whether or not we can get interleaving of publishers and subscribers, or whether they all, yeah, there we go. Now check it out. So when we get enough events being published, now we have 5,000 events, you can see that the subscribers are now running in parallel with the publisher. So that will give you an example of how we really truly are using multiple cores on my multi-core Mac in order to be able to do the processing in parallel, which is kind of cool. So we'll just shut that down. That would run for a while because there's a lot of numbers to compute for primality. So this is a really fun example, and it demonstrates a whole bunch of cool features in Project Reactor. And one of the things we're going to do later in upcoming weeks is we're going to take a look at this program again, but add a whole bunch more features to it. We're going to add support for back pressure. We're going to add support for various kinds of strategies for dealing with overflow. And then we're going to show an example where we take this simple code that all runs in one process on one computer and split it up using the web flux mechanism in order to be able to run it on multiple computers or multiple processes. And so that'll illustrate the use of basically an asynchronous client server model in order to give you more flexibility and more scalability as well.